Hello and Assalamualaikum. My name is Nurfadzira binti Ahmad Tajudin. In this video, I will present my final year project, which is poster distribution, a case study of ninja van at Sungai Petani. First, I want to talk about research background in this study. Postal and courier services have been growing due to the high demand of the customer. Hence, providing better services is needed now more than ever, especially during the pandemic of COVID-19. To stay competitive, postal and courier companies need to give attention to customer satisfaction by improving their services. In Malaysia, Ninja Van is one of the preferred companies by customers to receive their item or to courier their parcel. Problem statement. Having lots of parcel to deliver, Ninja Van services definitely can be improved more. Based on Ninja Van social media site, there are complaints due to the late deliveries, which affect customer satisfaction and hence Ninja Van reputation itself. Instead of aiming to finish delivering shorter parcel, managing the route by choosing the shortest distance between the customer destination will avoid undelivered parcel and hence increase the efficiency. In this study, a postal distribution problem is considered where the problem is formulated as vehicle routing problem. Next, the main objective of this study is to minimize the length of delivery route for postal distribution. Other specific objectives are to determine the optimal strategy for postal distribution, to investigate alternative shortest route to take for postal distribution, and lastly, to get insight into the current strategy adopted by the postal distribution. Significance of this study. The optimal strategy found can significantly reduce the operation cost, deliver the shipment on time, and possibly deliver more shipment in a day since the route is shorter. Besides, it can guarantee customer satisfaction and loyalty since their package arrive in a shorter time. As for the company, good feedback attracts more customers, keeping the company relevant and profitable. Scope of study. The study focused on postal distribution at Sungai Petani, Kedah. The study covered the solution for vehicle routing problem using the digital method. The scope of the study is only for 1 month, April 2021, when the district Sungai Petani, Kedah is under movement control order. Postal distribution. The postal and courier industry in Malaysia is positively shaped by the recent launch of the Economic Transformation Program. Similar to other sectors, during this pandemic, the postal and courier industry is facing new challenges such as low profit margin, access to capital, technology adoption, and quality. Next is literature review. Northern et 2012 studied postal and courier services and focused mainly on customer responsiveness. Their study measured the services at the operational level, in which the delivery influenced the responsiveness. Song et 2009 proposed an algorithm inspired by new swarm intelligence named Route Planning Agent to solve mail distribution with the aim to achieve the faster mail transfer. Hollis et al. 2006 studied an integrated mail distribution problem. The purpose of this study is to find a low-cost set of vehicle route, vehicle shader, and crew shader based at numerous depots to deliver a given set of shipment. A study by St. R. 2015 proposed a mid-integer non-linear programming model for the postal distribution network, where they proposed a mid-genetic algorithm to reduce unnecessary head kilometer. A study by Apataloka et al. 2016 focused on the core of the urban decision support system. It is intended to assist decision makers in the organization of work shift by minimizing the travel time of the vehicle route in the shift. Data collection. The data is obtained by interviewing the current manager of Ninja Van Sungai Petani, Mr. Muhammad Ihsan. The information was collected for only 1 month, which is April 2021, excluding the 2nd, 9th, 16th, and 23rd of April, since every Friday is a holiday for the workers. This data is about postal distribution in the area of Sungai Petani, Kedah. The minimum parcel delivered is 19 per day, meanwhile the maximum parcel delivered is 155 per day. The actual data from Ninja Van indicate 155 parcels to be delivered. However, Google Maps is unable to determine the exact location of some of the customers. Hence, for the 17th of April, we considered 104 nodes only. Mathematical formulation. The objective function of the problem is given by 1, where the aim is to minimize the road taken by all vehicles. Constraint 2 is to ensure that each customer is visited at least once. Constraint 3 and 4 are to provide the start and end node. Constraint 5 prevent vehicle from returning to V node after visiting VI11 of set of customer, while constraint 6 ensure flow conservation. Constraint 7 and 8 are to handle the capacity. The output formulation are the route assigned to the vehicle. Solution methodology. There is 3 subtopics, which is K-mean clustering, Dijkstra algorithm, and the full algorithm of Dijkstra algorithm with K-mean clustering. Firstly, K-mean clustering. K-mean clustering begins with a random centroid initialization. The nearest cluster is then found for every data object, and the object is assigned to that cluster. After all data object has been assigned to the nearest cluster, the position of all centroids are determined using new cluster members. The process of assigning object to cluster and updating the cluster position is repeated in a loop. The K-mean clustering will stop when there is no further change in the centroid. In this study, a built-in function K-mean from the MATLAB Statistics Toolbook is used. Next is the Dijkstra algorithm. The Dijkstra algorithm begins at the node you provide the source node, and it analyzes the graph to determine the shortest path between that node and all other nodes in the graph. When the algorithm has determined the shortest path between the source and another node, that node is marked as visited and added to the path. The method is continued until the path contains all the nodes in the graph. As a result, a path connects to the source node to all other nodes using the shortest distance possible to reach each node. Next is the full algorithm of Dijkstra algorithm with K-mean clustering. The algorithm starts by clustering the customer by k equal to n number of clusters. The clustering is done to get the customer's destination that are close to each other. Then, the Dijkstra algorithm is applied for each of the clusters to find the shortest path between the customer. The clusters are then reconnected to build the square of distribution. The Dijkstra algorithm with K-mean clustering. There is 2 subtopics, which is the implementation of the K-mean clustering algorithm and the implementation of Dijkstra procedure. The implementation of K-mean clustering algorithm. The algorithm starts with K-mean clustering. This figure illustrates the underrated graph network for 12 of April to the 31 consists of the distribution center 0 and n equal to 14 number of customers. The date is chosen as it has the lowest number of parcels. Tabulated in this table is the corresponding cost network that represents the distance between all the customers and the distribution center. The distance table is built using Google Maps. Firstly, apply the K-mean clustering to all the customer nodes. The number of K chosen in this study is 3, so the customers are divided into 3 clusters by using the K-mean MATLAB Statistical Toolbox. This figure shows an illustration of the cluster found. Then we proceed with using the Dijkstra algorithm for each cluster. The implementation of Dijkstra procedure. This implementation is explained using cluster 2. The Dijkstra algorithm starts with node 1 and ends it with the further in the cluster with each 4. This is chosen based on the cost network. Then, the sub-cost network for cluster 2 is inspected and node to connect with the current node is found. Starting with node 1, by Dijkstra, it will connect with node that has the shortest path with node 1, which is node 14. The distance between node 1 and node 14 is 0.26 km. The connected edge is 114. After that, node 14 will connect to the node that has the shortest path to node 14, which is node 5. The distance between node 14 and node 5 is 0.35 km. According to Dijkstra, the distance between node 14 and node 5 needs to sum up with the distance of the node that has been chosen before, which is the distance between node 1 and node 14. The sum of the distance is 0.61 km. Then, the sum of the distance needs to be compared with the distance between node 1, the node before node 14, and node 5, which is 0.55 km, to choose the shorter distance. Therefore, 0.55 km is chosen since it has a shorter distance. Hence, the new distance is 1.16 km. Then, this will proceed until all the nodes in cluster 2 connected. The same procedure is applied to cluster 3 and 1. The clusters are then connected by the shorter distance that connect the end node of each cluster. Results and discussion. The algorithm proposed is written in MATLAB R2021A and runs on 4GB RAM with a 2.40 GHz computer. The algorithm is implemented for 4 days from data collected in April 2021, consisting of the lowest, medium, and highest number of parcels to be delivered. specifically the 5, 12, 17 and 19 of April with 19, 14, 104 and 25 number of parcels to be delivered respectively. This table tabulated the best sequence found for each day considered. The shorter distance were also tabulated. From the table, the sequence for the day with the highest parcel have a distance of 69.56 km, which is more than twice compared to the distance for the day with the lowest parcel, which is 23.45 km. Conclusion of this study, the algorithm found the optimal sequence and the shorter distance for the 4 days. The 12th April 2021 has the shorter distance with 14 parcels to deliver to customer, while the 17th April 2021 has the highest distance with 104 parcels. The distance are proportional to the number of parcels. Results show that K-mean clustering and digital algorithm is a good method to apply for finding the shortest path. Recommendation: other alternatives where it can use to find the shorter path are A-star algorithm, prim algorithm, and also genetic algorithm. This research can be furthered by considering the actual weight instead of relaxing it. Hence, you can see how the vehicle capacity is utilized with actual weight. The result found can be compared with the exact algorithm by using commercial software like Lingo.